In this video, we're going to be talking about how to find perimeter and area of a rectangle. So let's talk about the formulas that we need to find perimeter and area, and then we'll do some examples where we solve. Here's our most generic rectangle. In a rectangle, opposite sides are congruent. We're going to call the base the side that is perpendicular to the height. So really, it doesn't matter which is which, but in general, base and height are perpendicular to each other. We could also draw a diagonal. There are two of them. We'll just draw one. We could symbolize it using a lowercase d. So we could call this base and height. We could call it length and width. It doesn't really matter which is which. To find the area of a rectangle, it's the same formula to find the area of any four-sided shape or any quadrilateral. It's base times height. So we could keep it at base times height or change those words to length and width, if that helps. To find the perimeter, slightly different from a square. We have two equal sides, two pairs of opposite congruent sides. So if we have two bases that are the same, we could just multiply the base by 2. If we have two heights that are the same, rather than add, we could multiply that by 2. And since both of these are being multiplied by 2, we could actually factor a 2 out to simplify our formula and say that it's just double the sum of the base and the height, or double the sum of the length and width. To find our diagonal length, we need to think about this right triangle. It's not necessarily a special right triangle, although it could be. But either way, in order to solve for that diagonal, it's just the hypotenuse or the c value in the Pythagorean theorem. So we could do a squared plus b squared equals c squared and change those letters to be b squared plus h squared equals d squared. And we could solve each of those variables and have 3 different versions of that same formula. If that's too much, you could always just start here and then just solve for whichever piece you need to solve for. Either way, though, these are just your Pythagorean theorem equations. So let's find perimeter and area in these examples. In this example, we're given the base, we're given the height. So we could find the perimeter by using our perimeter formula, add up the base and height, and then double it. So 5.2 plus 3.8 is 9. Double that and we get our perimeter is 18. The same thing you would get if you added up all of your side lengths. To find the area, we just need to multiply base and height. So 5.2 times 3.8 is about 19.76. So to find the area, just multiply your length and width dimensions. To solve for this diagonal length, let's practice using the Pythagorean theorem. It's just the c part in our a squared plus b squared equals c squared. To solve for d, we're going to square root both sides. So we have the square root of a squared plus b squared. Or in other words, 5.2 squared plus 3.8 squared under the radical would give us 41.48. If we square root that, we get about 6.4. In this example, we're given one of the dimensions and the diagonal length, so we need to solve for the other dimension. In order to do that, it's just another version of the Pythagorean theorem. You could call this a or b, it doesn't matter, we're solving for it. So we could set it up to say the square root of c squared minus a or b squared. So the square root of 13 squared minus 12 squared. That would be the square root of 25, which turns into 5. And maybe you already knew that because you are familiar with the special right triangle that has these dimensions, 5 by 12 by 13. Anytime you're missing one of those dimensions, you should automatically know what the other value is. That will always be a true scale of a right triangle. Also, any scale factor, so if we double these numbers or cut them in half or triple them, doesn't matter. As long as they're in that ratio, these are the values. So now that we have our width, let's call it, or you could call it the height. Now we can find our perimeter. We're going to add up our base and height. So 5 plus 12 is 17, and then we're going to double that and get our perimeter is 34 inches. To find the area, we just need to multiply our base and height, or length and width. So 5 times 12 is 60 square inches. In this example, we're given the diagonal length and an angle of our right triangle. Since we're given 30 degrees, we can assume that its complement over here will be 60 degrees. And so now we have a special right triangle, a 30, 60, 90 right triangle. And we have some properties we can use to take some shortcuts. So to find this width, it's across from the 30-degree angle. So this would be our shorter leg in that triangle. And that shorter leg is always half the hypotenuse. So half of 14 is 7. If you were unaware of that, you could still use trigonometry to do it. You could say the sine of 30 degrees is equal to opposite over hypotenuse, or W over 14. And the sine of 30 is actually 0.5 or 1/2. So when you multiply it by 14, you take half of it, and you still get 7. To find the length down here, that would be the adjacent side to the 30-degree angle. So you could use trigonometry still and do the cosine of 30 degrees is equal to the adjacent over hypotenuse sides, or L over 14, and cross multiply, and you might get a decimal that's pretty close to 12.1. But we could also think about those properties of that special right triangle. This side length right here is across from the 60-degree angle, making it the longer leg. And we know that the short leg times the square root of 3 is the longer leg. So we could just say it's 7 times the square root of 3, which is equivalent to that decimal value we found by using trigonometry. Now that we have our width and our length, or our height and our base, we can find the area. We just multiply those two things together. Multiply the two numbers that don't have radicals. So 49 is in front of the square root of 3. Or if you use the decimal value here and multiply by 7, you should get approximately 84.9-ish, which is equivalent to that. To find the perimeter, we add up all the side lengths, or we could add up our base and our height and double it. But in trying to do that in radical form, these are unlike terms. We cannot add them together, so we could distribute that 2 to simplify this expression. So 2 times 7 is 14, and then 2 times 7 times the square root of 3 would be 14 times the square root of 3. Or we could just do it all in decimal form and get about 38.2. In this last example, just words. So anytime you're given a math problem in words, it might help to draw some pictures so you can visualize it. Underline important information in the words. It says the width of a rectangle is 5 inches less than its length. So if we say that L is the length, then L minus 5 would be 5 inches less than that. We're told the area is 14 square inches. So in order to find area, we're multiplying length times width. So if we instead multiply L times L minus 5 and set it equal to 14, the area, then we could solve for L. We could distribute. L times L is L squared, and L times negative 5 is negative 5L. We could subtract 14 from both sides to get a quadratic equation in standard form, and then we could use quadratic formula or an X-factor technique to help us solve. If we're factoring to solve, we need to find factors of negative 14 that add up to negative 5. We could find factors of like negative 7 and 2 that do that. And then we could write those in our binomials and find the zeros of each of our binomials. So L minus 7, what makes that 0? Well, just positive 7. L plus 2 equals 0, what makes that 0? Well, the opposite would be negative 2. So we have two solutions, but only one of them actually represents a length that we can use. So we're just going to use the positive 7 solution. So L, or the length, is 7 inches. The width is 5 less than that, so the width must be 2 inches. And now we have our two dimensions to find perimeter. Add up our length and our width and double it. So 7 plus 2 is 9. We could double that and get our perimeter of 18 inches. To find the diagonal length, we got to go back to using the Pythagorean theorem. Take the square root of our squares of our dimensions. So 2 squared plus 7 squared is 53, and the square root of that is just a decimal. We can't actually simplify that in radical form. It's about 7.3 inches.